Hello everyone, my name is Bharadwaja Satya. Vinod. I am from the telecommunications department. My topic is communication systems related to electricity transmission and distribution infrastructure in future grids, under which I have selected my research question was strong and sophisticated encrypted SG systems for the power generation transmission under the subject of Engg 955 engineering research methods. When the electricity industry is now on the string of replacement era and era that promises through the evolution of prevailing electricity grids to smart grids, more efficient and effective power usage, best reliability, reduction in production process, and more eco-friendly energy generation. Numerous initiatives across the globe, led by both industry and academia, are usually in the implementation process, and we do have experimental projects as well. It is the concept of power generation on renewable energy that has raised when fossil fuels are depleted. This process can be useful for the power generation, enormous benefits, but also the great risks introduced by this evolution. This mainly focuses on insurance related to the security of a smart grid as an integral part of the smart grid. Based on several scenarios, there has been numerous studies on research studies of are being conducted to improve the development and enhance the smart grids by implementing the best possible research for the digital world. And this would be an interesting task where developing a strong and sophisticated encrypted system like firewall for the system to withstand the cyber intrusion and attacks in the system mainly produce green energy without disturbing and affecting the environment. So generating and distributing storing the power generated is the main task of this proposal. An effort to shed light on open issues and future research concludes. Well, the initial concept of smart grids raised from what if the fuel are depleted. So renewable energy was their ultimate choice. Since smart grid can be implemented not as the contrast to the traditional power generation with implication of wireless technologies, smart grid can implement it. The study and implementation of smart grid is not an easy task. With the origin of wireless technologies, power generation and transmission is being coupled with energy management system. Software-defined networks gradually evolve and enhance SG cellular communications are effective and stable where LTE is a promising approach. It plays a key role. This has resulted in more research and experimenting with SG. This includes research on cellular communications, distribution systems, energy transmission systems, distributed energy sources, energy storage security, and power in data transmission. There has been numerous studies. Smart grids are the technology for automation in power grids, transmission, distribution, as we can measure and analyze power consumption with automated metering infrastructure. Grid automation, the excess energy will be sent back to the power generation and then storing take place. However, pros and cons of SG are being established to create an experimental or operation model in various environments. SG is based on an intelligent system where control layer and data transport distributed systems worldwide interoperability for microwave access communication, cellular communication, hybrid automatic repeat request, data acquisition systems. This network is a lot of this is a lot of cluster of computers and a power transmission networks. To build a sophisticated network, LTE approach is also one of the most uh, network scalability issues. Well, the internet with the advent of digital world, we are living in a digital world with the advent of internet. SG is much more vulnerable to the attacks of the cyber intrusion. But the cyber attack security of privacy of data over channels have been that most important. The electric power infrastructure, as we realize it today, has to manage the serves our need successfully. Needs for reliability, scalability, and environmentally friendly energy generation, interoperability, and cost effectiveness. Conventional power grid is a replacement to the fossil fuels, and it is in a direction. So the idea of smart grid evolved from the where SDN software-defined networks help smart grids to gradually evolve. Through this, enabling two-way communication between utility and customer sites while pointing the tanks to a more incorporating of renewable energy sources to grid both, where uh, power generation and power transmission has been coupled with energy management system where energy is efficiently transformation of conversion and power grid to the is undoubtedly is an inefficient and reliable process where existing SCADA and EMS systems are now being refurbished. SCADA systems are the vital systems for critical infrastructures where a power control system is one of such system, public transportation another. Various studies show the security of grid is strictly dependent on authentication, authorization, privacy, technology, and privacy technologies are well measured. Federal Information Science Systems approved advanced encryption systems and triple encoding systems to specific the privacy solution required will depend upon the sort of communication, whereas these critical data become the primary target of hackers in future cyber physical coupled grid. Security requirements of in smart grid that must be availability, integrability, and confidentiality. The prominent requirements are privacy, authorization, non-repudiation, identification, and authentication. These are two types of data transmitted between these devices. Private and operation data are the two types. They provide a layer communication architecture with a secured channel is necessary, whereas distributed energy like wind and turbines belong to premises forwarding the consumption of data to the neighboring collection points. Flexible system like plug in and plug out expansion optimization storage quality checks are large utilized. Securities within the smart home grid environmental usually attend to compromise one or more of the security as described. These threats can be classified into two categories. Firstly, passive attacks, and then second, they attempt to learn from the attack, and secondly is active attacks. The attempt to alter system resources or affect it involves modification of the data or introduction of fraudulent data into the system. Sensible grid is being established to supply the necessity of strong security requirement for the smart grid. Grid various technologies like are being used like cellular communication, LTA, SCADA systems, SDN security, SDN networks, WiMAX, while consistent with IPRI. Cyber security or physical attack by an adversary may be a mischievous customer. The most common among these tasks are masquerading replay message. Different wireless protocols have been varying degrees of security mechanisms supported by the safety requirements for smart grid. Utilizing public key infrastructure technologies alongside trust computing elements supported by other architectural for used for the LMR counting on the reliability. WiMAX cellular uh, SG is an allocation authorization. The security requirements they violate of threat. The data is very useful for the system monitoring and control due to its accuracy, synchronism. This critical task has been also been the identification, smart access control, and reliability. A smart grid system must support all or some of the electricity generation, distribution, transmission, and control operation to ensure that these transactions communicate securely. To ensure that these transactions communicate securely, enable to main security objectives and bidirectional communication, providing a layered communication architecture with the secure communication channel is necessary. Smart grids consist of many devices. These are two type of data transmitted between these. However, the smart grid research have been proving that creating some strong encryption to the operation has been difficult and tough, but further directions are being taken to constant modification of the security and privacy measures of the data generated. Thank you.